So in this lesson, we'll look at finding the angle of intersection between two lines. So step in determine the angle of intersection. So if you remember, we are using cos theta, which is the dot products. So the problem here is, what is the vector that we're going to use? So in this case, if the parametrics or symmetric equation is given, so dalam sebuah kat sini kita dah biasa dah cos theta ni kita guna nak cari angle between two line, we are using the dot product. So kita dah biasa dah guna dot product. Cuma sekarang vektor apa yang kita patut pakai? So you can look at this one. Step in determine the angle of intersection. So determine the vector ABC. So kat sini kita akan dapatkan vector ABC yang parallel vector tu. So which is the parallel to the line parametrics or Cartesian form, and then define the angle of intersection by the formula cos theta. Kita guna kaedah dot product. So you can look at this one. This example, find the angle of intersection between line 1 and line 2. So from line 1, dia punya ABC, daripada line 1 ni, ABC ni adalah di depan T ni. 2, 3 dan sini 1 lah. And then line 2, 5, 1 and negative 3. You can see L1, 2, 3 and 1. L2, the ABC is 5, 1 and negative 3. So this is the parallel vector. So kat sini you kena ingat, nak cari vector tu, kita akan guna parallel vector. And then formula is using the dot product. If you look at exercise 8, given that L1 and L2, L1 is the symmetric equation, where L2 is the parametric equation. So for symmetric equation, this one actually is, ini sebenarnya adalah over 1. Here is z over minus 2 over 1. So for L1, untuk titik L1 ni, untuk line L1 ni, our A, B and C, the parallel vector, actually is 3, 1 and 1. And then for L2, nak cari dia punya A, B and C adalah nilai di depan T ni. T, negative T and T. So in this case is 2. Yang pertama 2. Yang kedua negative 1. And the third one is 3. The T which is 1. So this is the ABC from line 1, the parallel vector. And ABC which is the parallel vector for line 2. So ingat 3, 1 and 1. In symmetric equation, jika you masih ingat the symmetric equation, dia punya general form is x minus x naught over A is equals to y minus y naught over B, and z minus z naught over C. A, B, C dia adalah di bawah. This is symmetric equation. Parametric equation, x is equals to x naught plus T times A. Y is equals to y naught plus T times B. And Z is equals to Z naught plus T times C. So A, B, C adalah di depan T, ataupun ada masa soalan dia guna S. So di depan S lah. So that's why saya guna T kat sini untuk A, B, C. So yang ni di bawah ni. Jika dia tak ada, maksudnya means that over 1. It's 1 lah. This is over 1. So now we have two vector. In order to find the angle of intersection, we are using the dot product. Kita akan guna kaedah dot product. So means that let's say I use L1 and L2. You can use this one. Cos theta is equals to let's say L1 dot product with L2. Divide by the magnitude of L1 times magnitude of L2. So ini nampak macam keliru. I can, let's say, I use others lah. U and V. Dot product of U and V divide by the magnitude of U times magnitude of V. So from this part, cos theta, also, I try to find it separately. Means that I try to find the dot product dulu. So let's say dot product of U and V is equals to 311 times dot product with 2, -1 and 1. So 3 times 2 plus 1 times -1, ikut turutan dia, plus 1 times 1. So here is 6 minus 1 plus 1. Here is equals to 6. And then we try to find the magnitude of U. Is equals to square root of U is 3, 1, and 1. So 3 squared plus 1 squared plus 1 squared. So here is 9 plus 2 is square root of 11. Then magnitude of V is equals to 2, -1, and 1. Square root of 2 squared plus -1 squared plus 1 squared. So here is 4 plus 1 plus 1, 4, 5, and 6. Square root of 6. So here is square root of 11. Finally, cos theta is equals to the dot product of UV, which is equals to 6 over magnitude of U and V, square root of 11 times square root of 6. So theta is equals to cos inverse 6 over square root of 11 times square root of 6. So from here, you should have square root of 11 times square root of 6. And then 6 divided by the answer. And then shift cos answer. You should get 42.39 degree. So this is the answer for the angle of intersection for line 1 and line 2 in exercise 8.